Okay, let us go ahead and we'll get ourselves started again. I just want to kind of think about this example a little bit further in terms of these kind of grid points and thinking about doing something in a polar kind of fashion. As I look at this, I only have sort of one sort of thought about it in terms of as we're thinking about the points. And as I go through and I think about this grid and how it might be used for placing different objects, the problem I sort of can try to anticipate, or I might anticipate out of this, is that, on the inner circle, those points are so incredibly nice and closely spaced. On the outer circle, we're getting pretty far apart. Okay, so that may not be the most useful in terms of if I really want to try and capture some behavior and really see what the effect is. I might want to have a kind of better spacing. In fact, I could even think about the spacing between the points being related to the length of the curve. That way you somehow have a relationship where the longer the curve is, the more closely spaced the points are, the smaller the curve is, the more closely, or the farther apart the points are spaced, or ultimately the number of points is larger in the big curve, ending up with a relatively even spacing. So let's think about how you can do that. Just kind of add this to it, and then we'll go ahead and complete this out. Of all the different things that are available to us, the whole notion of dividing the curve up, in terms of this XYZ array, that's certainly available to us. Another function that's available to us is really just the whole notion of the length of a curve. So actually, maybe I'll go the other way. Curve, I'll try even the curve instead. Curve this, curve that. There it is. There it is. Analyze, measure, curve length. So let me drop that one in. Let's take a look at what it does. If I drop that node in and I link the circles to it, zoom on in there, so we'll see what it actually looks like. You give it these different lengths. So the different circles right now have a length of 31, 65, 99. Okay? So as we think about those and we try to come up with a formula that says, really, how many points would we like to have, or really the distance between the points we would like to have there, kind of affecting that kind of ultimate the count. We'd like to kind of vary the count based on that so we have something relatively even. What we can do is think about actually just dividing that up. So for example, if in the outer curve we actually want to have 20 points, and on the inner curve we want to have 6 points or something like that, we could go through and just divide this list by 5. Okay, and come up with a number of points and use that as the number of points as opposed to kind of a just set number. That's going to be radiating out, almost like rays coming out there. So to do something like that and really have more evenly spaced points, what we could do is just put a divide in here. Okay, and then based upon the curve length, maybe feed that in there and divide it by some number. Just really some number that we think is going to, based on the length of the curve, going to give us a good count for the number of points that we should have in it. So I'm going to divide that by 5 for right now. Okay, what that's going to say, that doesn't look good. Oh, that's interesting. Creates a number. That's actually interesting. Yes, let's try that. Got a second one in there too. Still says infinity. Why am I getting dividing by infinity? This one over here has some nice feed over there. Thank you. Looks like it was, actually, it sort of makes me wonder in the whole scheme of things about the, well, it sort of seems like, well, it's open. You didn't have the foot on the tail end of it. Well, we'll see.
Okay, so now we have this whole notion of, okay, these different number of points. We can go through and plug those in. Okay, and now you'll see we actually start getting something that's a little more kind of evenly spaced on all the different curves. It's not radiating out in even arrays, but it is kind of looking a little bit better in terms of giving us some even spacing where all the different boxes or spheres are going to go or cylinders are going to go. Let's think about this in terms of, even in terms of the length. Yeah, what I would love to actually, I'd love to have like a length slider, which is going to be an interesting thing too.
We both have crashing on Dynamo.
Oh, no worries, it's in unison. Not to worry. What I can do is take this and even apply some sort of a factor on here. So for example, as opposed to just sort of a single length, what I can do is like basically tie some sort of, what I want to do is basically multiply those two together. What I wanted to do originally was I was going to try this. That looks like it might actually work. Let me see. It's interesting, even as an integer, and I would say this is a little bit of inconsistency in the whole thing. I have feet, I'm able to divide through by an integer, and it's actually, no, it's returning feet. But then in turn, it's interesting that that is willing to then go through and relate itself back to a count. You know, it's doing some sort of a transform in there where it's stripping it off, which that doesn't seem very good as a way to do it. I think the better way to do it would be to sort of go through and kind of reduce that over there. The cleaner way would be to basically say that this is like 1 foot, and then multiply these together. This would be cleaner programming in the scheme of things. So that now I get a consistent feet, and then go through and use that as my divide. So depending upon if I want very few, or if I want a very close spacing so that all the points are very evenly spaced around the whole thing. Okay, the tail end of this story is actually just the same as it has been in the other sort of examples. If we want to go through and put spheres on here, or cones, or cylinders, whatever it is, not to worry. What you have to do is just make sure you just have one of those things loaded in. So in this case, any preferences? Would you prefer spheres, domes, or arches, cones? I go for cylinders. I like cylinders for some reason. Come back over here. We'll say, again, select family. We'll go ahead and choose that cylinder. And then out of that, we'll create a family instance. Where we'll take the type, we'll take all those XYZ points, and with any luck, where am I? We're there. That should be creating a lot of instances. It looks like it's creating a lot of family instances. Let's come over here, look at it in 3D. I'm not seeing anything. Am I looking at the right file? I think it should be there. Let me try the other file just to make sure I didn't actually put it over there. Nope, those are still those. Come back over here, back to project 2. Oh, you know what I bet it is? This is always really goofy. It's because it's a mass element. Okay, the masses just aren't visible to me. Hang on, let's pop those back out. So there they all are, with very large radiuses. Okay, so once we have this, we could go through and again set element parameter. And for each of those different elements, go through something and like change their radius. And we'll just make it simple now. We'll just make it a simple number. But you could go ahead and make that more interesting. Okay, it's doing a little generating in the background there, adjusting them all. That's interesting. That's what it's doing. Why doesn't it like all my cylinders with a radius of 1? Element type. I don't know. I'm a little confused about that one. Oh, radius. Is that radius? That's radius. String. Let's see what it has to say over here. It says empty, so it's not liking something. The reference object is not valid. It's deleted from or is created and undone. That's a little strange. We think the family instances are there. We think those are there. I'll take out my node and try again. Radius, number of instances. Okay, that's a little bit better. So now I have these guys hanging around. Okay, now so far we just sort of played around with those. You can really quickly start to imagine how you could, from that, start also adjusting the height and really kind of adjusting the height in different ways. Yeah, you can think about all of these different things that you might want to have happen. For example, yeah, if I was looking at that in section, yeah, it's currently like, oh, it's all relatively kind of uniform right now on the inner and outer radiuses. Okay. We can start adjusting that in interesting ways. You could go ahead and think about relative to the center point. Right there. Doing something where, oh, for example, if you thought of this as an amphitheater, which is kind of an interesting way of looking at it, and you wanted to make sure that basically everyone had visibility, kind of down to the center of the stage, okay, we could go ahead and control the heights by doing some sort of simple calculation. We could say that the height is just sort of directly related to whatever the distance is, so that height versus that distance. And kind of compute the distance and use that to set the height. Okay. If you want to actually think about having some sort of a relationship like this, where you're going to be able to control the height so that for maybe there's a viewing angle you're trying to impose for the bowl or the amphitheater or something like that. Yeah, the height might be equal to what? It would be the distance times the sine of the angle. Where there's actually some sort of angle in here. And then based upon the angle you put in there, you go ahead and kind of control those heights. You put that all together. Okay. What you're asked to do for the assignment is actually something a little bit different. It's to control the heights based on some sort of distance where you actually want to put some sort of sine wave in there to kind of create the ripples or something like that. But at this point, it's all like 4 different variations on the same thing. Okay, so from that, hopefully, that'll give you plenty to get going with about whether you want to go through and do that with a rectangular grid or whether you want to do that with a polar grid. In the assignment, I'm asking for a rectangular grid, but if you like polar grid instead, I think that's fine too. If you want to go ahead and take this up and go with this way instead. Okay, so sort of make sense? Beauty. Okay, let's go ahead then and change our focus just a little bit. Okay, into some new stuff. Hopefully that'll get a lot of that stuff anchored down. And what I want to take a look at is just a couple of functions. Okay, we've been dividing these points on a curve. That we've actually been doing a pretty good job of. Let me come back over here. So we did the sine wave. The points on a curve we actually ended up doing quite a bit by placing the points on the curve. We ended up doing it around the whole notion of selecting the circle, but really dividing the curve into a number of points and then maybe adjusting that so it's a different number of points on each of the different curves, kind of based on the radius. Okay. Placing geometry at the points, that's whether we want to place a circle or we want to place a family instance on the points. That's about the same. Okay, and so we're doing pretty good on that one. Okay, next thing up we want to kind of take a look at though is this whole notion of creating a curve from reference points, and that's kind of an interesting one. And we can really loft together curves out of really almost anything. And to do that, what we really need to do is basically just feed it a couple different points. Okay, then build up a list of the different points so it can tie them together into a single list, and then create a curve out of them. Okay, and then we can go ahead and use that curve to go ahead and put things on. So let's go ahead and start with that. If you come on back to, let's go over to, it's the next example, I think it's 4.3. Let's take a look at that. Curve by points. So here's the idea behind this one. This one, we basically have a curve that's really defined by 3 points. I've also subdivided it into kind of a number of points on top of that. But let's start by just dividing it, or just creating the curve itself. And to do that, let's just go into the add-ins and open up the Dynamo environment. Okay, and we'll open up the scripting behind all this. Let's say open. How about we will start with, let's go to the endpoint first, and then we'll back off to it. Say curve by points end. So in some ways, this won't look all that incredibly surprising to you. What we have is, really, I've set up a series of different sliders for ultimately the X, Y, and Z to create a point. And I set up a series of sliders to create a second point, and ultimately create a third point. So it's just 3 different sets of sliders creating points. So out of each of these 3 different things, if I go ahead and run it, there will be just a point, where the value is really just X, Y, Z based on whatever's happening over here. Okay. Out of those points, we're going to go ahead and create something called reference points. Let's talk about that. X, Y, Z points are points in geometry. They don't really have points in Revit space. They don't really define anything out in the real world. They're just pieces of geometry that we're using to hang things on. Reference points take it to the next level. Reference points say, hey, given those X, Y, Z coordinates, let's actually go ahead and put a point in Revit that we can then hang something on. We can hang a parametric part, we can hang a curve, we can just hang some piece of the real building geometry off of that. And that's what we're really doing, is going through and creating 3 of those different points. And ultimately using those points to generate a curve. Okay, so if you want to get started and play along here, how about this? Come on back to, I'm going to open up the other one, which is just the starting point, curve by point start, which doesn't have it all filled in. but we'll take a look at what it's doing. And I'll even run that. And hopefully you'll see that what's going to happen is, based on some coordinates for this first point, x, y, z, they have some sort of coordinates of 6, 5, and 3.89. It's going to generate a reference point. Okay, and if I pop back over to Revit right now, let me go ahead and take out this one here. That's kind of cluttering up your view right now. Let me run that again. You'll see it's just creating a point. There's this little point hanging around in space down there. Let me zoom on in just so it looks a little bit better. Okay, it's a little hard to tell where it is. If I go orbiting around, you might see that, oh, it's above the plane, it's at some x, it's at some y. Okay, and if we go through and start moving now, let me even go to turn on run automatically so you can just sort of watch it move. You can see I can move it in the x dimension. I can move it in the y. I can move it in z. And we'll move it up instead. Okay, so this point, this little lowly point, it seems like a very, just kind of a simple concept, but it actually is the beginning of something very, very powerful. Okay, as soon as we go ahead and have a point, and then we start multiplying them, if we have 2 points, we can actually start to have a curve. Now, a 2-point curve is not all that interesting. It's a line. Okay, but that's okay. It's still a curve. It's sort of a very boring curve. Okay, as soon as we have 3 points, then we start getting to be very interesting curves. Because what Revit will always do is it will try to do the best fit curve, make some sort of a spline between all those, and ultimately try to create a very smooth curve between them. Okay, and that's what's happening here next. So in the Dynamo example, let's do this. I have 3 different sets of sliders down here. The first one's generating a reference point. Let's go ahead and actually just generate a reference point by the second and third one, too. So to do that, all we really need to do is either copy that node or go ahead and add that node after those x, y, z coordinates. So if you want to, whichever you prefer, just go ahead and say reference point. Drop it on in there. Maybe I'll copy and paste that on down for the next one. And I'll link that over to generate that point. And link this one over to generate that point. Super. Since I am running automatically, I should hopefully have, let me kind of zoom on out here. There we go. 3 different points in space. Okay, and again, we can orbit them around. Okay, or if you want to, just start changing the sliders around. So just watch them move a little bit. So the x value of the second point, you can sort of slide it around a little bit too. Okay, so let's say you can get yourself 3 different points kind of hanging around in there. Okay, feeling pretty good? Okay, if you have 3 different points, we are ready to start actually defining a curve out of these points. And defining a curve is actually not all that bad. What a curve wants is, let's see if I can move it over here. Curve by points. Okay, and what curve by points wants is basically a list of reference points. Okay, so I got 1, 2, 3 points that are hanging around loose over there. I'd like to get them back together into a list so they're actually understood as being an ordered list where those points are going to be determining what's happening in a specific function or in a specific order. So here's how you need to do that. If I want to create a list and get them all together, what I can do is start out with an empty list and add a point to the list. Okay? And then what I want to do is basically pass that list on down and add another point to the list. And pass that point on down and add the third point to the list. Okay? So let's see what that looks like. It's an empty list. So far it's kind of hanging around empty. Over here you'll see it's a list of 1 point. Over here it hasn't been evaluated yet. There's nothing else in there. If I drag this point in and add it to the list, what's going to happen is what was a list of 1 just became a list of 2. Okay, and in an ever so similar fashion, let's go ahead and copy that and paste it on down. I'm going to pass the 2 list down to this and add the 3rd point in. Okay, with any luck, that's now a list of 3. Okay, so that's how we aggregate those lists. And because I've built that list of 3 different points kind of hanging around down there, and I've come down to this corner of the logic diagram, you might guesstimate that I'm going to take that list and actually feed it into here to create a curve. Okay, and ultimately, okay, we'll leave it at that for now. I'll take this one out. Now, so far, it doesn't look like it quite did enough. Notice it's still waiting on one other value over here, this isRef. IsRef is going to be a Boolean, so it's going to be a yes or no. And it looks like it's required, so we need to go ahead and put some value in there, a yes, no value. That's going to be, whether it's a curve or whether it's a reference curve, which doesn't mean much to us right now. It will mean more later. I'm going to go ahead and say, hey, let's go ahead and make that a curve. Tie it in there. Okay, and now we have a curve that are tying those 3 things together. Okay, so if we can tie 3 points together, you might ask if you can go ahead and tie 4 points together. And you can. You can tie 5, really as many different points as you want to add to this. It'll keep on kind of extrapolating and extending this thing. So, for example, yes, if I wanted to go through and just really connect another point to this whole thing, I could do that. What I could do is just gradually grab all that logic right there and copy it and paste it. Okay, now I basically have control of the 4th point. And with that 4th point, what I can do is in that same sense, actually, it's going to be sitting right on top of one of the other points because the values are still the same. Let me kind of move it around a little, just so it looks different. Shove that out of the way. Okay. I should be seeing a 4th point kind of hanging out there, looking a little bit loose right now. If I want to get that 4th point integrated back into the curve, what I need to do is, in that same way, just add to the list, copy, paste. What I'm going to do is just pass the list of 3 in, then grab that 4th reference point, put it in here. Hope that's a list of 4 now, and then feed that list in as a list of reference points. And now we have some fantastic custom fitting curve to 4 points. Now, this is still pretty mundane in terms of what's going on, but what you got to start thinking about is this is how we can actually start generating surfaces out of any number of points. Because if you fed me a list of 1,000 points, okay, and I start subdividing them into curves, I could then create connect all those curves together and really create any arbitrary surface. And as opposed to trying to model that by pushing and pulling the curves in Revit, just being able to do it numerically, that gives you the ability to kind of really use all sorts of very interesting calculation algorithms to generate the values of that points, and the Revit surface will adapt to it. Okay, so very powerful to get started with. Yes?
If you go to the Revit model and move the points around, do they get automatically moved in the...
They do not. Let's kind of take a look at it. Since these are programmatically generated, like I can stretch it, okay, that's going to be good there. Let's see what happens if I do the run again. I think it's going to push them back, but a very good question. Now it's interesting. It's actually letting those dominate, which actually sort of makes me wonder. That was 0.3, all right? So let's see what the value of it is in the XYZ. 168, 165. Okay. Oops. 149, 278. Now it's actually, yeah, it's going to make a liar out of me, right? That's okay. I don't have the right answer. That was 0.3, right? 149. No, I'm trying to figure out what the relationship is. Yeah. What I expect to have happen is that it won't let you go ahead and move them manually relative to that. That either things are sort of programmatically moved or manually moved, something like that. Although you can have a model that mixes the two things together. We can have a model that mixes programmatically placed points and manually placed points. And then just the ones that are programmatically placed will always adapt to the new programming and vice versa. So again, that's 0.3. Let's see what's happening over here. It doesn't look like it's doing what it's doing. Although it is interesting to me, I think that it is, as best I can tell, it's honoring the override that we put in there, which is kind of surprising to me. That's the fourth point down there. Yep. So I'm a little confused about why it allows us to let us do that. Alas. Okay. Once you've gone ahead and placed these points on there, you can still do all sorts of things like subdividing this curve. Yeah, that's what I kind of did in the last little piece over here, but we don't have to do it here as much because all it is we can take that curve, we can put some number of points in there, whatever the number is, 5 or 6, and if we want to subdivide it, we can, but we've been doing that all along, so that's not too interesting at this point. So great, we'll go ahead and put 20 points on that curve or put an integer slider, whatever it is. Okay. Oh, I take that back. You're not seeing anything right now because those are just XYZ points. Okay. If I want them to actually be purple points kind of over in the model, what I have to do is basically make reference points out of them. So copy and paste. Okay, and now, with any luck, should have a lot of reference points hanging around in there. So we can start subdividing curves and use those after we've chosen some really interesting organic curves. There we go with that. Okay, to finish today, let's just kind of take it to the next logical extreme though, and say no to that. Where the next logical extreme in all this is that really you'd like to be able to kind of take these curves and actually create a surface out of them. Okay, and to do that, let's open this last one, surface by curves. And you'll see that really within here, it's the same basic sort of logic. Let me go ahead and open the add-in. Okay, and in terms of what's going on over here, this is not going to look all that dissimilar. So let's go out here. I'll just go to the ending point first. This will look pretty similar. What I have is basically 3 points going to reference points for one curve, 3 points going to reference points for a separate curve, and basically aggregating all the way down to creating curves out of those points. Okay, so that's the tail end of that story. Is that curve by points and curve by points over here. And the final piece of this is actually to go through and try and link them together. So the way we actually link together curves to make a surface is, if you can handle the notion of a list of points making a curve, if I get a list of curves, I can then make a surface out of it. So what I got to do is the same sort of thing. I have curve 1 and curve 2. I start with empty list. I'll add the first curve to the list. So at this point, let me go ahead and run it. It has a certain curve. I'll add a second one to the list. It has 2 curves. And the final thing we're doing is just lofting those 2 surfaces together. Okay, and that's what actually goes through and creates the form. So if you want to take a look at what that looks like, just in the background there, that is the surface that's really created by the 2 different curves. Kind of orbit that around so you can start to see it a little bit better. So you'll see this is actually kind of a very, interesting undulating surface. It'd be hard to go through and modify or to kind of create that in sort of a, or in most other ways. Let me go back over here and just start changing around the curves though. For example, one of the curves is really defined by x, y, z. So let me kind of just start messing around with the middle curve value and sort of see if we get the curve to change itself. So if I move the x out, am I running automatically? No. So if I move the x out, move it way back, it's folded back. Let me move it way forward, it's folded forward. If I move the y value, or the z value, what's going to happen is basically the curve is flexing in the background just in response to that. Okay, let's do that where you can see it a little bit better. Now that got to something where it cannot do it. That happens every once in a while. We can overly bend something and crash it too. So maybe we'll leave it right there because that's a good place to leave it for today. So go ahead and if you can, play around with that example and just push around the XYZ points and see if you can start folding that curve. What we're going to do next time is we're going to actually take that surface and divide it up into a whole series of UV panels and then actually start using that surface to place parametric like skin components onto it. Okay, so different things that will use all those different points and the dividing of the grid to go through and actually start placing either structural elements or skin elements, something like that. So please go ahead and play with that. That's where we're going next time. Get yourself updated in terms of software. It looks like 0.63 is a good place to stay for right now, relative to finding all the different node names. And if you can, just dive in and if you can sort of just knock that first assignment out, because it's pretty straightforward in terms of what we've been doing here. And we'll answer any questions we can and be done with that and keep going. Okay, so let us adjourn today, and we'll keep on going next time.